Hello, all. Let's start with our today's DSA Journey with this amazing visualizer by ChaiCode.com at dsa.chaicode.com. Use this link to get a 7-day free trial. And today is our last question. Simple LRU cache. Not simple. The question is tough. So design a data structure for the least recent use cache with the fixed support get and put value both in big O of average time. When the cache is full, evac the least recently used. Okay, so this is our question LRU cache. But before going to LRU cache, let's understand LRU cache. Okay, so an LRU, least recent use cache, is a memory management algorithm used by operating systems and hardware to decide which piece of data or page to evict. When the storage limit is reached, it removes the item that has not been touched for the longest time. Okay, so in cache, what we do is we store values or data or everything. Okay, so you see, when we are storing that value, we have to ensure that we just remove the least recent value. Okay, if you go to the question, I already solved it here. It is a medium mark, but you need to understand everything here because this is a long code. So design a LRU cache. Okay, so we have to do three function: one class or a constructor, another get function, another put function. So constructor is simple: initialize the LRU cache with positive size capacity. We have to initialize with the capacity of the size. Return the value of the key if the key exists, otherwise return -1. Okay, so we have to find something that we are given a key. We have to go and find that is the key present in the cache or not. Okay, so update, and what is put, update the value of key if the key exists, otherwise add the key value pair to the cache. If the number of key exceeds the capacity of the operating position, evac the least recent use. Okay, now, and this is let's come here. So we are using two approach here. Okay, rather two approach, we are using one approach. We are using a double linked list and a hash map. Okay, so what is a double linked list? Okay, so till now we are given that this. So this is a singly linked list that this goes type. Okay, so one has the area or the point where the 2 lies, 2 has the address where the 3 lies, 3 doesn't have the address where the 2 lies. Okay, so in the doubly linked list, what we have to do, we make the selection. Okay, same thing, but we also have this one. So this one knows the address of these two, and the two also knows the address of the one. Okay, so previously we see that in this singly linked list, what we have been doing, like, okay, so we are doing simply like integer value, then node star, simply like next pointer. Okay, this is simply a singly linked list concept. Okay, this is the singly linked list work. Singly linked list work, but for the doubly linked list, we got a next pointer also. We have a previous pointer, so we have to add this thing. Simple, add this thing for a doubly linked list. Okay, so this is the concept of doubly linked list. Now we are using a doubly linked list. Also in the linked list, we are actually taking a value here, but for this question, LRU cache, okay, we are taking two values. Here you can clearly see we are taking two values. Why two values? Because we need two values. Okay, because every time we have to search something by the key. See, actually, when you come here and read the question, this portion, this void put, this put, put simply insert value into the cache. So when you insert value into the cache, what are the things we are inserting? We are inserting one key and one value. Okay, as a key value pair. Okay, add the key value pair. So that is for that reason we just have like let's take the pencil, something like this one. So we have something like key value pair. Just suppose that something 7 is the key and 5 is the value. Okay, so this is our portion. You can clearly see like LRU. If we go to this example, this 1 has 1, then again this put, this 2 has, the key 2 has value 2, then again this key has value 3. Why we need key? Because when we search into the cache, we search it by the key. We just go to that key, take the value from there. Simple key value pair. Okay, so this is how our doubly linked list look like. This goes to a next pointer, this goes to a previous pointer. Okay, now how this approach works. So we need a doubly linked list. Okay, first let's suppose we take put. Okay, let's suppose we have to take put. First take the put. So this is our head. We just take a dummy head here. Also, we have to make sure we have a dummy tail. So what is that our tail? Our tail is simple this -1 and -1. Head and tail is the null pointer. So head next pointed to this tail and the tail previous pointing to this head. This is the pointing to null, tail next pointing to null. Okay. Now suppose we have to insert this one, this same thing. Our key is suppose 1 and our value is 5. Our key is 1, our value is 5. We have to insert. So where should we insert? Just after the head. Okay. So just remove it, take it, put it here. Now the head next pointing to this and the tail previous is now pointing to this. Next pointing to this tail and this previous pointing to this head. Okay. Similarly, take another example. Okay, this is how actually we take it. Now take an example. Okay, -1 and -1, and here is also the tail is -1 and -1. Let's suppose we have two pointers or we inserted two values like 7 and take it like 7, 5 and take another node which is nothing but and 6 and a 5. Okay, so key, now this head point to this, 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 now goes to this and this. So this is our head and this is our tail. Now we have to insert something. Okay, so recent use. Okay, when we have to insert something, we have to insert it just after the head like here, and when you have to delete something, we have to delete just from here. Okay, because after inserting values every time when you inserting values one by one, so make sure that that value is currently used. So if we insert a value in the head at the starting, that value is currently used because we are deleting from the end. Okay, and we have to make sure that list recent use. So how actually we could insert a value at the head? So suppose we have a pointer, let's take it as 5 and 4. This number are just random. Okay, so suppose this is a temp pointer. We take a temporary node. We just take a temporary node, and this is our head and this is our head next a. We can easily do it by head next. We can easily got this point a. Now this head next should point to this, and this should be broken. This a pointers or the a node the previous of this a node should point to this, and this should broke this node, and this temp previous node points to head, and temp next node point to this a. So now see, if we remove this, if I remove this, okay, remove, okay, just remove this. Now it is just insert into the loop, into the list, not the loop, into the list head, then this temp pointer, then this whole thing one by one in a tail. This is how actually we insert our nodes into this doubly linked list. Okay, when we have to find something, okay, we just take a map which stores simply value of like integer, which is simply the key, and also the node which is nothing but the node that we are using here in doubly linked list. Okay, and when you have to delete something, suppose we have to uh, delete this, we have to delete this node, we have to delete. Simple. We just make sure one thing. Simple, because the a, or suppose this is our deleted node, let's take it as temp, because now remove this temp, remove this. So take this temp node, this is something nothing but a. So a next goes to this tail, the tail previous goes to this. Okay, so this node get blocked, this node get breaked. Okay, then simply you can remove this too. This simply remove this node. Okay, so if I just remove this, it just remove it. So this node is not a part of the list. Okay, but so this is our list. We see our delete and insert. But now if I just do one thing, if the node gets repeated, so the head next, suppose this is our list, and again our memory hit this 6 and 5. This is the same node, this is already present, but this is now recently used. This node is now recently used. So we have to make sure that we just remove the existing node from the list, which is this one, and add the same node to the start. Okay, so when we actually inserting one node, we have to check one thing, that if we found the node or not. So if like we found the node 65 here, so our first task will be remove this node. How could we remove this node? Suppose this is a temp node, a temporary node, this is nothing but a. So this a next goes to this tail node, and this tail, and this loop, these two pointers, and not this, these two pointers are broken, and we can easily make sure to point this pointers touch. Okay, so this is the two node we are now breaking. Okay, simple. Now this 6 5. Okay, now they remove this 6 5 from here and take the 6 5 here. So just a minute, this is nothing but our temporary node. Okay, so it previous still call this and it next still call this. Okay, this is our current situation, and we can easily now remove this. Okay, so this is our current situation. Now we have to insert this node at the head. Simple. This is temp, this is a, this is a. So simply how we do it here, same thing. The head next, goes to this step. Okay. This head next goes to this temp, and we just remove this. This a previous goes to this node, we just remove this. Now this 6 5 next goes to this 7 5. Okay, this 6 5 or the temporary next goes to this 7 5. We just put it there, and the sorry, the 6, this is nothing but the previous. Yeah, or I just remove that. So this is the something that it actually have, but we don't go there. So the previous now pointing to 7 5 and this next pointing to this null. So we just cut this next, and the next now pointing to this 7 5 or this 7 5. Then this previous is pointing to 7 5. We just cut this node, and this previous is now pointing to the head. Okay. So if we just remove all the removing nodes, just now this head, then temp, then a, then tail. See, everything is on the line in a perfectly manner. Okay, this is how we can insert and delete node from here. So if we see there, design a problem, build a with both of one, and simply this is how the animation works. This is actually the exact pseudocode that I will be using. I don't do any extra things. So this is one of the pseudocode, one of the best pseudocode that I have. Just go through it. Okay, let me write down the code and go through the pseudocode, because I understand the problem by writing the actual code rather than going to the pseudocode. Okay, so this is our empty thing. First we have to create a doubly linked list. Simply make a class node type. Yeah, I'm doing this, and the class has two things: int, a key, and a value, and two pointers. One is next and one is previous. Now write down the constructor. Node take like int underscore key and int underscore value, the key value pair, and add the key here and also the value here. So simple constructor. Okay, so our constructor, and okay, let's write. Let's after this writing down our doubly linked list class, just do one thing: create head and tail. So what is our head and tail? This is our head and tail. So head and tail is nothing but two nodes with -1. Key value pair is -1. So node star head is simply new node and -1. Why I put comma here? Because when we create this node, this -1 goes to this constructor, and put into our values. Okay, similarly we have to create a tail, which is nothing but uh, to node -1 -1. So now we have to initialize the cache. Yes, H cache. Now first initialize the cache. How to actually initialize the cache? Okay, and to initialize the cache we need another thing, which is nothing but a capacity. We need this capacity actually in the future to check. And first thing first, the cap is going to be capacity, and head next at the starting. Remember, at the starting what we are doing before having this node, we just took one head node and one tail node, and we just pointed like this way. This is a raw diagram. Okay, so same thing we have to perform here. So the head next is point to tail, and also the tail previous is point to the head. So this is our simple LRU cache. Also with this capacity, so how actually we could find a key? Okay, so we have to find a key, and for that reason we have to store it into a map. Okay, we have to store it into a map. So just create a map. Like, I think I should create this after this. Ordered map, int and node. Okay, text mp. So this int is nothing but the key. With this value key we search element, and this node is nothing but our doubly linked list node. Okay, so first search in the map. Okay, now first search in the map. Okay, when we have to search it, we have to let's do it on the way. So first search in the, if we have given key mp dot find. Okay, equal to mp dot end. So it simply means the key actually already in the key actually already present in the map. It simply means we have the key already in the linked list. So the map, actually the map stored only the values only present in our linked list and nothing else. So first uh, extract the node from the key. So it is simply node star. What should be the naming? Mm, what should be the naming? Our name. What should be our name of this node? Or um, give me a minute. Actually, give me a minute. Take result node and simply of mp of key. So we take the node. Now erase. Okay. Take the node. Take the node and erase the key from the map. So mp dot erase the key. Okay. Now our step would be delete the node. Okay. delete the node. Actually we have to write the delete node function by ourselves. So delete node, simply this node. So this delete node function delete all the links from the linked list. Okay, and after that add the node at the starting. Add the node simply at the starting, which is simply add a node and raise node. Now now the entry in map. How to make sure make an entry in map? It is nothing but mp of key. mp of key, we just add our new map. A map is the key at our map, and why after adding the node, after adding a node, what should be the pointer? So when we add a node here when you add a node, what will be the node position? The head next. The new node is always on the head next, so it is nothing but simply head next. Yeah. And return the simply, okay, we have to return the value of the key if the key exists. Okay, so for that we have to take the value part from the linked list. So take it as result, which is nothing but it's a node value. Okay, so simply return the result, and if now no value found, then simply return -1. Now write this delete node and this. So first uh, let's delete it. So our function is simply delete node, and it take a node star. What should be our point? Delete node should be the function. So take node star del node. So our node name is del node. So when we are deleting something like here, we need this a. Okay, or if there is no tail. Okay, not the tail. So if we have to remove this 7, okay, so we need the previous and the next, because we when we are deleting one node, we have to make sure the previous of this value pointing to the next of the value. Okay, so if we want to delete this node, we have to make sure this previous value point to this next value. This is our simple logic. Okay, so for that we first need a next node. So simply del next, which is nothing but del node next, and take the previous node, which is nothing but del previous. Simply take del node previous. How can we do it? Previous, because we are having two pointers. So our previous and current now point. Now what you have to do, our previous next should point to our the next node of the current of the deleted node. So simply our this del previous next should point to, and this del next previous should point to del previous. Simple. This is our delete node. Now we just complete our delete node. Now add node. Add node and node star. We have to add a new node. Actually have to add a new node at the starting. So take it as new node. And when you have to add a new node, what do? We just take this head and the head next. We need these two, and we have to add. So first we have to take this a. Okay, take this A. Let's take it as temporary. The temporary node, which is nothing but the head next. Now, this new node next should point to this head. Okay, the new node next should point to this temporary. Now, this new node previous should point to this head. Simple. Okay, so this new node previous point to this head. Simple. Then our head next, which is currently pointing like this, you have to make sure to point like this. So our head next is nothing but now pointing to this new node. Now our temporary previous, which is currently pointing like this, should point like this. Okay, so our temporary previous should point to the new node. So this is our add node functionality. Simple. Now come to this put function. Okay, what does this put function do? Update the value of the key if the key exists. Okay, add the key value pair. Okay, so if like 65 as we exist, but we have to insert one value with a new key, same value with a new key. Okay, so first we have to check it. Okay, or can I just copy it from here, or I have to just write like this one, or write it. If we found the value, so if the mp dot find the key is not equal to mp dot end, it simply means we found the value. Okay, so if we found the value, just delete the existing node. Okay, delete the existing node. So first take the node temporary node. Let's take it as temp, and because we are using the temp node, because we just use this temporary here. So this node temp is nothing but mp of key. So delete node, I think the would not be problem. This temporary node. Okay, so delete the temporary node. Now, and another time when we could when you have to insert one value, suppose when you have to insert one value but the cache is full. Okay, so if you go there, it removed the item has not been touched for the longest time. Okay, so the longest time, one thing that has not touched is the last element. So when the cache is full, we have to remove this last element. Okay, we have to remove this last element. How could we get this last? Simply the tail previous, because everything is in doubly linked list manner. So if we go like here, so we have to remove this node. So how could we reach this node? Tail previous. Simple, we reach this node when the cache is full. So if the cache is full, so if the cache is full, so if if the capacity, or and we can easily find it like mp dot size is equal to capacity. So we just initialize our capacity as cap in the above everything. So whenever we use this capacity, we are actually using this capacity. So you can easily check. So the capacity is full. When the capacity is full, we have to erase the node. Okay, so just simply erase from the map. So mp dot erase. Okay, where now I will show the solution. So mp dot erase. So simply tail previous. Actually search everything by key into the map. Okay, so we need the key, not the value. Okay, now we have to delete our node. So we have to delete our node, which is simply which node we have to delete? The last, the last of this tail, which is nothing but tail previous. Simple like that. Now we have to add. When we have to add node, so first create a node. Okay, so simply our add node, call our add node function and create a new node using what? Using this key value. So simply new node is, sorry, key value. Have to check it. We have to add one node and we have to add it to our map also. So add it to the map. So mp of the key is pointing to where we are adding the value, at the head next. So simply add the head next and nothing. This function is void, so you don't have to return anything. So this is our whole code. So let's just run it. Calling a private. Oh, so this error happens calling a private constructor of the class LRU Cache node. Okay. So what happened is when we are actually do write a class, by default everything is a private variable. Okay, so we cannot access everything out of the class like we are accessing this node out of the class. So for that we have to make sure everything and then simply I just do it. Now this should run. Yes, it's running perfectly fine. Okay, it gave a wrong answer. It simply means we make some mistake somewhere. The get should be okay. Let's see where I make the mistake. Everything is okay. Let me check one time. When we are deleting one node, we have to ensure that that node should be removed from the map also, because we are storing everything into a map. Now it should work. Yes, it's working. So the mistake is simple. Here we are just not removing it from the map. So this is our whole function, whole process of LRU cache. Now come to the pseudocode. So get if key not in the map, return -1. Okay, so if key follow this and return the value, otherwise return -1. Otherwise check it, see everything, return the node value. move the node to the front. Okay, so that we just deleting our node, then we move our node to the front, or we just add node, because it is much more easier to delete the node and also add it to the starting. Okay, simple. Then the put function, if key is in the value, then node value is equal to value and move to front. Okay, so simple. Like if we don't, if key in map, okay, else let's check it here, like else. So if key in map, okay, so this is the simple thing. Like if we found a key in map, then simply node value into value and move forward the node. Okay, so we just delete our node here, but after deleting here we actually add our node at the starting. See it here. And if the size equal to capacity, we just we just remove the tail. So we just remove the tail using the size equal to capacity. And else insert the node at the front. Okay, so at the end insert the node at the front. So this portion, we just make this portion common to everything. So if it is happen to this or this, every time this portion works, that actually mention here, like if else, if else. So we just doing it using only two if statement. Okay, so this is our code. Simply big O of 1 as a time and big O of capacity as space. Go solve this problem. Use these diagrams to solve this problem, like you do linking between them. Go and read this pseudocode. This is one of the best pseudocode. For that reason I am not writing anything. Okay, so this is a pseudocode and just doing this for the sake of doing this. Okay, this is the first one. We just nailed it. So go use this, solve this problem, use this link to get a 7-day free trial. Use this platform at dsa.chaicode.com. Thank you very much.